When solving differential equations, like this one right here, dy dx equals cosine x, we can actually do this rather quickly by finding the antiderivative. Right? We know that the antiderivative of cosine x is sine x. So our general solution would be y equals, that's an equal sign right there, sorry, sine x plus c. Okay. So this is our solution. Now, we can actually graph this on a graphing calculator. Right, so I'm going to bring my graphing calculator in here for a moment. Right, and notice what I've got. I've placed in all of my y's sine x minus 4, 3, 2, 1, and then sine x, and then sine x plus 1, 2, 3, and 4. So there's 9 sine graphs. Now, what's the graph of this going to look like? So if I hit the graph button, I've changed the window already. That's the graph of all those sine functions. All right, and that's, so in essence, that takes care of, you know, c being any integer between -4 and 4. It looks like this. All right. So this picture right here, this rainbow colored picture, is the solution to the differential equation, right? Because it's representing the sine of x plus c, and the sine of x plus c we know is the antiderivative of cosine x. Now, what we're going to do here is we're going to create this graph, okay? But we're going to do so without touching sine x. We're only going to work off of cosine x. We're only going to work off the differential equation. And the reason why we're going to do that is because sometimes we get a differential equation which is not easy to antiderive. If you flip your notes over really quickly, look at this differential equation in example 5. dy dx equals x plus y. Now we're going to get to this example in a moment. But this is not something that we can easily antiderive. Right? Cosine of x was an easy antiderivative. Right? It was equal to the sine of x plus c, so this is our solution, and this is the picture. Oops, my bad. Hold on a sec. Let me go back to the graph. This is the picture of our solution. Okay. What I want to do with you now is I want to make that picture on this graph using cosine of x. And the way we're going to do, what we're going to do is we are going to create a slope field. Right? So, what I need you to do now is just quickly glance down at key point number 3. To complete a slope field, what you're going to do is you're going to plug in any coordinate pair into the differential equation. All right, so we're going to take any point from here, and we're going to plug it into the cosine of x. Right. And we're going to get a result. Remember that the derivative is the slope of the tangent to the curve at a point along the way. So we're going to, at that point, we're going to draw a short line segment that has the slope that we found in part A. So that's the idea behind the slope field. Okay. The next video is actually going to show the slope field being made.